Okay, so in this video we're gonna basically talk about trigonometric functions and topics related to them. We're gonna cover the concepts of law of cosines, law of sines, and the inverse trigonometric functions, which would include the graphs, domain and range. Also, we're gonna see the concept of the simple harmonic motion and the sinusoidal curves, as well as their characteristics and their applications. Finally, for theory, we're going to see the different applications in real life for sinusoidal curves and the trigonometric functions. And we're going to solve two problems that were lent to us for the project, and that would be it.
Hi, my name is Sofía and I will explain the theory for this project. So the normal sine inverse graph looks like this. The domain is included minus 1 to included 1, and the range is included minus negative pi over 2 to pi over 2 included 2. For the cosine, the inverse function looks like this, and the domain is included minus 1, negative 1 to included 1, and the range is included 0 to included pi. For tangent, it looks like this. The domain is included negative infinity to infinity included, and the range is not included, negative pi over 2 to pi over 2. For cosecant, the domain is negative infinity to infinity, and the range is negative 1/2 of pi to 0 or 0 to pi over 2. For secant, the inverse looks like this. The domain is negative infinity to infinity, and the range is included 0 to pi over 2. And for the inverse of cotangent, the domain is negative infinity to infinity, and the range is negative pi over 2 to 0 or 0 to pi over 2, not included. This is like the basic formula to graph any sine or cosine or anything, and here you can see the amplitude would be A, the period would be 2 pi over B, the phase shift would be negative C over B, and the vertical shift would be D. The amplitude is the length of the elevation of the function measured from the center line, and it would be the same if you measure it from the highest point or the lowest point. The period is the length from summit to summit, or also it can be called the full revolutions, and it is measured 1 over frequency. Frequency is how often something occurs per units of time. And the angular frequency is the number of revolutions or periods something makes in a determined period of time. In radian is the unit. Angular frequency is 2 pi over period. Phase shift is how distant is the function horizontally to the right from the normal location of it. The formula is negative always, so that means that the sign will always change, and the direction where it moves will also move as well. The simple harmonic motion is characterized by the movement of a piece located on a spring, which is vulnerable to the line elastic restoring force explained by Hooke's law. This movement is sinusoidal in time and proves a single resonant frequency, and this is the formula.
So the problem number 1 says the screen in a theater is 22 feet high and is positioned 10 feet above the floor, which is flat. The first row of seats is 7 feet from the screen, and the rows are 3 feet apart. You decide to sit in the row where you get the maximum view. That is, where the angle theta subtended by the screen at your eyes is a maximum. Suppose your eyes are 4 feet above the floor, as in the figure, and you sit at a distance x from the screen. So we have this diagram, and we can get another angle here, which we are going to call alpha. So part A of problem number 1 says to show that theta equals inverse tan of 28x minus inverse tan of 6x. And as we already saw, there is another angle in the drawing that is called alpha. So tangent of theta plus alpha would be 22 plus 10 minus 4 over x. And then you have to do this addition, which is 28. So tangent of theta plus alpha would be 28 over x, and then you have to leave this angle alone. So first you have to do theta plus alpha equals inverse tan to eliminate tangent of 28 plus x, and then you only leave theta alone, which would be inverse tangent of 28 over x minus alpha. And on the other hand, you do tangent of alpha, which would be 10 minus 4 over x, and then you subtract, which would be 6 over x, and you leave alpha alone, which would be inverse tangent of 6 over x. And then these two equations, you make them equal, and you get theta equals to inverse tangent of 28 over x minus inverse tangent of 6 over x, which is the one that the problem gave us. Now part B of the problem says to use the subtraction formula for tangent to show that theta equals inverse tangent of 22 over x squared plus 168. So we have that this is the subtraction formula. So we know that a equals to 28 over x and b equals to 6 over x. So what we are going to do is to substitute these values in the original formula. So it would be inverse tangent of a, which is 28 over x, minus inverse tangent of b, which is 6 over x, equals inverse tangent of a, which is 28 over x again, and b, 6 over x, over 1 plus a plus b, which is 28 over x multiplied by 6 over x. And then we have to clear out this part of the equation, so we multiply each one by x squared, and we get that theta equals inverse tangent of 22 over x squared over x squared plus 168 squared over x squared. And this here the x simplifies, so we get 22x over x squared plus again the x simplified plus 168. Therefore we have that theta equals inverse tangent of 22x over x squared plus 168, which is the one that the problem was asking for. This is the second problem. Now suppose that starting with the first row of seats, the floor of the seating area is inclined at an angle of alpha equals to 25 degrees above the horizontal, and the distance that you see of the incline is x, as shown in the figure. So this is our diagram, and now we're going to solve it. So for the second part of the problem, it says, now suppose that starting with the first row of seats, the floor of the seating area is inclined at an angle for alpha equals to 25 degrees above the horizontal, and the distance that you see of the incline is x, as shown in the figure. A. Use the law of cosines to show that theta equals inverse cosine of a squared plus b squared minus 484 over 2ab, where a squared equals to 7 plus x cosine of alpha squared plus 28 minus x sine of alpha squared, and b squared equals to 7 plus x cosine of alpha squared plus x sine of alpha minus 6 squared. So as we had seen in the figure, 22 was one side. So using the law of cosines, we get that 22 squared equals to a squared plus b squared minus 2ab cosine of theta. So we have to leave 2ab cosine of theta alone, which equals a squared plus b squared minus 484. Therefore, theta equals to inverse cosine of a squared plus b squared minus 484 over 2ab. And as the problem told us, we have that a squared equals to 7 plus x plus cosine of alpha squared plus 28 minus x multiplied by sine of alpha squared. And we have that alpha equals 25 degrees. So we substitute that in this equation, and we get 7 plus 0.9063x squared plus 28 minus 0.4226x squared, which is a square binomial, and we have to do that. So it's first square 7 multiplied by this and multiplied by 2, and the second square. So we do the same for this one, and we get that a squared equals to this. We already got a, and now we have that b squared equals to 7 plus x multiplied by cosine of alpha squared plus x multiplied by sine of alpha minus 6 squared, which is what the problem told us. And we also have to substitute cosine of alpha for 25 and sine of alpha for sine of 25, and we again get the a square binomial, and we have to do the same thing, which is the square of the first one. You multiply the two numbers and multiply them by 2, and the square of the second one, and we get this. And then when we do the addition, we get that b squared equals to 0.9999 squared plus 7.6169x plus 85. And then we have to substitute a and b squared in the equation that we previously got, which was cosine, inverse cosine. And then we have to substitute all of the values here, and we get this. And from this equation we have to go step by step simplifying it until we can no longer do anything. Like here you multiply the square roots and you get this, and to eliminate them from the numerator you have to multiply them by the same square root, which is this step, and then you join all of the similar parts of the equation. You get this, and then you continue to do the same. So as simplifying the equation as much as you can, you get this final answer. It says to use a graphing device to graph theta as a function of x. In this case we used GeoGebra, and estimate the value of x that maximizes theta. In which row should you sit, and what is the viewing angle of theta in this row? To get the x that maximizes theta, we get this as in the previous problem from the graph. And in the graph we get that the maximum value of x is 9.295 feet. And from that x we have to get the value for theta, which in this case would be 0.867 radians or 49.6754 degrees. Therefore, we should sit in the fourth row.
So the formula to get the cosine curve, or the sinusoidal wave for cosine, it's a times cosine of the period, which is W in this case, and all by x minus the horizontal shift plus the vertical shift. So in order to get the amplitude, we need to get the maximum value and the minimum value, all divided by 2. So in this case it's 158 minus 9 divided by 2, which is 74.5. So the next part is how to get the period. Well, the period you get by multiplying 2 times the time of maximum value minus time of the minimum value. In this case, the times are in which 0 is the year 1975. So in this case, since there are 2 different periods, we need to get both of them. So in this case it's 21 plus 11 all divided by 2. And in this case it's 16 plus 5 all divided by 2, because there are 2 different periods. This is the maximum value, and our maximum value is here, and this is a minimum value, and this is another minimum value. Therefore it's 2 times 16 minus 10.5, because you already got both of these. So it's 2 times 5.5, which is equal to 11. So in order to get the period, we need to divide 2 pi divided by 11, which in this case would be 5.711. Okay? So now that we all got that, so it's time for the vertical shift. The vertical shift is gotten by the maximum value plus the minimum value all divided by 2. So in this case it's 158 plus 9 all divided by 2, which would be 33.5. So now the only thing that's left is the horizontal shift, which would be the times maximum value, but there are 2 times the maximum value, which is the 4th and the 5th one. So you sum both of them up and divide it by 2. So it's 4.5. Now the formula went in like this. So its amplitude, which will be 74.5 times cosine, and the period, which will be 5.711 all x minus the horizontal shape, which will be 4.5 plus the vertical shape, which will be 83.5, and that's how you get formula. That's how you get the formula for the sinusoidal wave for the problem 9. So this is how it ends. This is the cosine wave in sinusoidal waves, and these are the different sunspots for the graph. So it starts in the year 1975 and ends in the year 2004. No, 2004, sorry. So this is y, in which this is the amount of sunspots per year, and x is the years in which happened. The formula has already been told, but basically this is how it ends. Well, so in order to get the last part, which is D, we need to get all the data which is here, put it in GeoGebra, and then use the análisis de regresión de dos variables. And then after that one, what you have is we're gonna use this, and then you have it. You need to put sen here, and you get the formula and the sinusoidal curve for sen.
So sinusoidal curves may be applied to examine music, since sound is the cycling between the compression and the rarefaction of air. When listening to music, different waves of sound with their respective frequencies are being heard, and in order to study these frequencies, sinusoidal characteristics may be taken into account. Okay, so sinusoidal curves may also be applied for modeling temperatures, because they represent periodic cycles. Since temperatures are tied to seasons, and seasons are periods of the orbit of the Earth around the Sun, climate changes may be registered and represented using sinusoidal models. Talking about temperatures, also a direct inverse function applied in this subject is the transformation from Celsius to Fahrenheit degrees. Trigonometry has several applications, and one of them is for flight engineering. In order for a plane to have a proper arrival, the pilot must take into account the speed and direction of the wind in contrast to those of the plane. For this, the speed and degree of direction of the plane, as well as the speed and direction of the wind, are taken as data to form a triangle that must be solved with the trigonometric functions, so that the plane travels and arrives with the force of the wind added to its course. Okay, so in conclusion, as a team, we think that this project is helpful to understand the behavior of functions and waves, specifically for trigonometric functions, their inverses, and graphs. We realize that these types of functions are present in things we observe in our daily and made us receptive about it. The concepts we learned did not only help us review for topics we have been studying in class, but also have a better understanding of the concepts. We all agreed that the understanding of these concepts will help resolve real-life situations that we were not aware we could. Okay, so I personally think that this project has helped the better understanding of the subjects studied in class, applying a harder phase of the subject and the investigation of concepts regarding the topic. With the research that was made, the uses of subject in real life matters were found with a clear understanding of the concepts involved, like what are sinusoidal models and their direct relation to trigonometric functions, as well as why are these themes important for a quotidian basis depending on the sector of application.
As a matter of fact, the project has helped us analyze and recreate certain parts of our daily lives. Although we use the theory a lot in our daily lives, it is a little rough and imprecise, but with this we can manage a lot more, and with a better concept and understanding of sinusoidal waves.
This project not only helped me to understand better the concepts we have been seeing in class, but also to know how to apply them outside school. I found very interesting the problem about the movies, because I know where to sit and have a better appreciation of the movie. I have a better understanding of how waves work and how they are grabbed.
So this project helped me to review what we had already seen in class and to practice it. And I also found very interesting the problem of the going to the movies, because going to the movies is something we do very often, and we always want to know what is the best seat or what is the best ticket to buy, but we never really think about how we could get that. And I had never thought that we could get that, and it was very interesting to know how can you know which is the best seat. And I also learned that trigonometry and trigonometric ratios apply to things in everyday life, like going to the movies, and that they also have other applications in professionals or for things we do every day. And I thought it was very interesting to find that.